All right, so applications of statistics, this is the module 8.03, and I just want to go over the big ideas with our measures of center. This is something you did last year with the mean being the average of a set of numbers, the median being the middle of a set of numbers ordered from least to greatest. Last year you also looked at outliers, which is a value that lies outside most of the other values in a set of data. It's much larger or smaller than most of the data, and it's usually denoted here with an asterisk. The other thing that you went through last year, it was mean absolute deviation. So this is the average movement away from the mean of a set of numbers, using the absolute values to calculate it. And just real quick, to deviate, again, it means to depart from an established course. So synonyms would be like diverge, to drift, to stray. So the larger the drift, the further away it is from that measure of center or our mean. Now you have a couple different types of problems, and one of the problems that you have gives you a set of numbers, and you have to determine if that set of numbers has an outlier in it. And if there is an outlier in it, then the best measure of center to use is the median, because it doesn't affect the middle number of our median like it would if we were to average the numbers. So for example, here with this list of numbers, we have 35 as an outlier. If I look at the median is 9. If I were to actually average these, it's about 11.6. So you can see there's quite a difference. And then the mean absolute deviation is 6.7, meaning it averages 6.7 higher or lower from the mean, which the mean in itself is already higher than our median. So when do you use the mean? Well, you want to use the mean when your data is similar. Meaning if we have this set of numbers where that last number is now 18, which is close to 15, now our average, our mean is 9.5, which is close to that median. And then our MAD, our mean absolute deviation, is 4. And you can see that only deviates 4 higher or 4 lower on average with the mean. And again, take into account that median is 9. So it's still very close to that measure of center. So this is the best one. So when you're looking at even, let's say, high numbers like in the hundreds of thousands, if you knock off those zeros, and you can find that they're fairly close together, unless there's like a huge gap, then I would use the mean. If you find that, let's say you have homes in the range of like the 100,000s, the mid 100,000s, and you get up to like the 10 millions or something like that, then I would just go ahead and use the median. And this goes into play in the next part. And Flora Virtual gave you 2 different problems, and these are very close to what you're going to see on your quiz, because the quiz only has 2 problems. So when you're looking at this first problem, it says Ariel wants to know if the number of words on a page in her science book is generally more than the number of social study in the social studies book. So she takes a random sample from 10 pages and finds the mean, median, and mean absolute deviation for the 10. And you can see here the science book has more words per page on average, according to the mean, than the social studies. But when we look over here, the mean is 60 for the science, and the social studies is 65. And then her mean absolute deviation calculation, there's a higher variability with the science book than there is with our social studies book. But she uses the mean, and she claims that that number, the mean number of words on each page of the science book, is greater than the mean number of words on the page of the social studies book. So she thinks that the science book has more words per page based on that data. Is it a valid inference? And it is not. So what we're looking at is one that has this high variability. It's much higher than the social studies. And if we have that high variability, we want to use the median instead, because the mean is easily affected by that high variability. And part of that could be that there's an outlier. All right, the second one. So here, Jordan uses the same data from Ariel's sample, but instead he looks at the medians to compare the books. He claims that because the median number of words on each page of the social studies book is greater than the median number of the words on the science book, the social studies book has more words per page. So based on this, is this a valid inference? And I would say absolutely, because we know that there's a higher variability for the science book, then we want to go ahead and use that median. And notice the median here is 65, which is close to the mean. And if you compare even the science book here, look at the difference between the mean and the median. There's a much greater variability even between these two measures of centers. So here, this has a lower variability. So because there's a lower variability, then our median is going to be the one that we want to use here. There is some overlap of data, but the median number of words on the page in the social studies book is greater than the median number of words on a page in the science book. So there is, like I said, a lot of variability in the science book, but not so much in the social studies book. It's better to compare the medians from the set of data because the median is not easily affected by variability. And this is what we're looking for here. So as you look through the problems like this is kind of key where we're looking for that, that valid inference. All right, so if you have any troubles, come check out my announcements for the Zoom times, and I will see you there. Bye.